went on a new page. Is that it?
Beautiful. Beautiful. All right.
Everyone watching Margaret learn how to use computers. Very fun.
Learning as we go.
Okay. Sphere. This is a classic one. And this one is pretty cool actually, because there's actually some spheres out there in the world. You got soccer ball, basketball, baseball.
The sphere in Vegas.
Sure. Yeah. This is a sphere. You could think of it as a 3D circle if you wanted to just be kind of wrong. But yeah, the volume of the sphere is volume equals 4/3 times pi times radius cubed.
There's that 4/3 again. 4/3 times pi times radius cube.
Yeah.
Lovely.
And a radius here is pretty much the same as a radius in a circle. You start at the middle of the sphere and you go out to any outer point of the sphere and measure it, and that will be a radius. And actually, this is the same exact formula as volume of an ellipsoid. It's just the volume of the ellipsoid has 3 different size radiuses, radii. The A,
Interesting.
B, and the C. So you really only have to memorize one formula. Just put a 3-dimensional axis in the middle of a sphere or the middle of an ellipsoid and multiply 4/3 pi by a radius going in each direction. Cool.
I like spheres. I like spheres a whole lot better than ellipsoids.
Yeah, but if you think about it as how they're basically the same formula for volume.
What's the formula for an ellipsoid?
It's volume is equal to 4/3 pi A times B times C. But here it's R times R times R, or A times A, whatever letter you want. It's just they're all different lengths or they're all the same length. So the formula can be simplified in one case and not in the other. Yeah, that was just a little interesting fun fact. Surface area for a sphere is equal to 4 pi r squared. Nice and
there I go again with the lowercase a. Watch me go. Doing my thing. You said what?
Surface area equals 4 pi r squared.
No, pi around.
Yep.
Hold for applause.
One of our father's favorite math-related jokes. We have only heard it 87 times so far in our
his story goes, there was this guy in grade school who said it about cornbread or something like that.
Oh yeah.
Very, very Midwest.
It's definitely involved.
Yes.
Okay. This is all self-explanatory, very easy. Okay. Let's do a pyramid, Graham.
Sure. Pyramid scheme or just regular pyramid?
Let's go with the shape first, and then a scheme maybe a little later. Square base and then 4 triangles that all meet in a point. That's what a pyramid is. If you didn't know that, maybe don't tell your Egyptian friends.
Ew. Shout out Cairo.
Yeah, they have some good pyramids over there, I've heard. Never been there. But yeah. But I mean, again, if I had like thousands and thousands of slaves to build pyramids for me, I'm sure I could make pyramids too. So
I'm glad we're going there. That's the direction that the podcast needs to go in. let's get to the dicey takes. That's what we need. But podcast idea, we go to the pyramids and do pyramid math at the pyramids.
Yeah. Take a little flight, find the volume of each of the Egyptian pyramids. What fun. The formula.
Well, here's the thing. We know the volume to do rectangular prisms, rectangles. We could just do it of all the rectangles that compose the pyramids. All right, what's the formula though?
Oh, and add them all up. Formula is 1/3 base times height. It's really easy.
That can't be.
Capital B though, capital B. Where this B is you kind of have to find its own area. It's the area of the base, which is base times height, lowercase. Yeah.
Oh, so then this height is also an uppercase, and that should be like that.
Oh, well, I mean, it
Something like that. I think people understand.
I like using different letters, I guess, but that's you really can choose your own letters. Okay.
That's true in application as well. If you're making software, you can name a variable anything that you want it to be.
Yeah, you do have to keep it consistent though.
You
That
do, and it is
is
helpful both in software and in math to be at least a little bit logical about how you name your variables so that other people can understand what you're talking about.
how about let's make the capital B equal to length times width. Let's do
Sure.
L times W.
Sure.
That'll be less confusing.
On the Margaret and Graham Math podcast, which, has a great name that's very original.
Yeah, it's a working
we can do whatever we want. All right, length times width.
Capital B is equal to length times width, and do a script L always when you're in math, because otherwise it looks like number 1.
Bruh, homie said don't do it like that.
Yeah, that's just like math 101.
Sure.
Never in your life should you, if you're handwriting, do a print lowercase l. Cool, and then do make our h lowercase again, please. And this is really all just personal preference, so just.
Man, I actually feel like I'd be able to do well in middle school math if I did it again right now. Maybe. I do not think that I'd get perfect scores.
Inspiring.
And I'm the host of a math podcast. Not a math podcast.
Middle school math wasn't even geometry. It was pre-algebra and algebra.
I'll tell you what it was. It was hard.
Great.
All right, moving on.
Moving on. Surface area, find the area of each side, add them all up.
Sure.
Just think about it a little bit and then do it. It's really not that hard.
Yeah, that's helpful. That's helpful when somebody is drowning in a hard math problem.
Just
think about it.
The trick with math is to sit and think about it, because a lot of times in math class, you get so caught up in just memorizing like the different steps your teacher showed on the whiteboard and just trying to do that robotically in every situation. Whereas if you actually understand the concepts and sit and think about each problem, you normally can just figure out what to do every time.
Yep. I'll say this. There is a plague in this country, possibly the world, of I'm not a math person.
Oh, yes, especially in this country, I think. It's like popular to be
I'm not a math person. I really know
bad at math.
What it means to not, be naturally blah 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 blah. But anybody can do math, and math is fun and useful, and this and that.
Here's the thing about math. No one is good at math. Math is hard. So you have to work at it and then you get better at it. And that's just a fact of life. And instead, everyone in America pretty much is being like, oh,
Well, not
I'm so bad at
everyone.
math. I'm
Definitely not
so
everyone.
cute. I'm so bad at math. Blah, blah, blah.
And we're not belittling people, and we're not making fun of anybody because this is an
Correct.
exclusive. And I didn't almost say exclusive. I meant to say inclusive podcast. All right, moving on.
Yeah, let's do a cone, Graham.
Sure.
This comes up all the time. Get some ice cream.
Cone. Oh yeah.
You know,
You know what?
driving through traffic, you see a traffic cone, and you're like, I wonder how much space is that traffic cone taking up in the world? Well, listen to us and you'll be able to put your questions to rest.
I would actually love to calculate the volume of an ice cream cone, especially if you had two scoops and they're perfect spheres, like perfect. Amazing.
Yeah, you just do volume of a cone, volume of a sphere, volume of a sphere, add it all up, good to go. You
All
know,
right.
okay.
Volume. I'm guessing some 4/3 is going to be involved in this.
No, 1/3, Graham.
My goodness.
Because it's kind of same thought as a pyramid,
Sure.
which is also 1/3. 1/3,
All right.
capital B, lowercase h, base times height.
Beautiful.
Now the height, go into the middle of the circle, which is the base of the cone, and then draw a line from that point to the very tippy tip of the ice cream cone, and that's the height.
I would not use the term tippy tip. Tippy tip to me seems top, and this is the bottom of the cone.
Well, you can draw the entire cone the other way. Like most
That's
of the time
true. I could have
in
done.
most
Well,
math,
you said ice cream cone, but that's how an ice cream
I
cone.
did, but
My head was
imagine
an ice
if
cream
it's a
cone mode.
traffic cone. Imagine if it's a traffic cone. And plus in most math textbooks, they do it the other way.
I now that you're saying that, I know that you're right, but because you said ice cream cone, I couldn't draw it any other way.
Well, this is an example of how like you're using your own creative thought processes to do something different.
And what's the base? The base is this
Exact
circle?
robotic. Yeah, the base is the area of the circle. So that's going to be
Sure.
equal to pi
Pi
r
r squared.
squared. Yeah.
Classic. What a banger.
That's what I would call the area of a circle as well, a banger.
I like that.
Yeah, cool. So that's volume.
Now,
Pretty easy. Surface area takes a little bit longer. So surface area, first, you have to do the area of the base because that's the
sure.
exterior surface. So do pi r squared. And then you do a plus,
Okay.
classic little plus
All
sign.
right.
And now we're finding the area of the cone part, I guess. It's pi r capital L. Sorry, lowercase l. Lowercase l. Oh, this script L.
Okay, so we've got pi r squared. That's for the base, and then pi r lowercase l. What's that lowercase l?
Great question. Lowercase l is called slant height. What do you think slant height is, Graham?
I think it's that.
Hell yeah, it is.
I mean, what else could it be? There's so few options.
There are very few options. But yeah, there we have it. Cones, done with cones, moving right along.
Cool.
Let's hit up a cylinder, Graham.
I am tempted to eat my next ice cream cone in the same way that it's represented in math textbooks, meaning upside down, and maybe just start from the bottom.
You don't think the ice cream would fall out, maybe?
I think it would, if I'm not very careful.
Well, maybe we can suggest to our teachers
Listeners.
of the world that the physics teachers and the math teachers work together with cones and gravity.
With ice cream experts?
Yeah. What are those called when you do a lesson that's kind of a bunch of subjects at the same time? What are those called? There's a name
Word
for it.
mosh?
There's a name for it. All right, cylinder, Graham. Give me a nice little cylinder, please.
Cylinder. Let's do it. Okay, so we're gonna do a circle on the top. Hey, think about that when we're thinking about. So if I'm thinking about area, I'm thinking maybe we're gonna do 2 times the area of a circle.
Yeah, for surface area. Yeah, I think you're pretty right. Here volume is
That's
base
why we're
times height.
co-hosts. Sure.
Straight up base times height. Mad easy. So see how it's the same? I would do a capital B again. See how it's the
I was
same?
thinking about asking.
It's the same as volume of a cone, except for times 3. And so you can kind of picture that, if you visualize one cone going down, another cone going up, and then they're kind of scooched to the side, and then there's another cone going up that's like overlaid across the first cone. Are you picturing it?
No, absolutely not. In
Look,
my mind, there's a monkey clapping cymbals going in a
okay,
circle.
look at the cone that you drew. You see it?
Sure.
Now,
Yes.
I want you to take the cone part and kind of like scooch it all the way to the edge. To the left, make a lot of room on the right side. Then take another cone, put it upside down like you're making a cylinder. Basically, take 3 cones and turn it into a cylinder. In your mind, you can do it. Quick question, why did you draw the number 3 after the H?
Because you said 3. You said it's the same except times 3.
It is, Graham. 3 times 1/3 is equal to 1.
Oh, got him.
Yeah.
Got him. Wait, so you're saying that it's you take 3 cylinders? I mean, so there's another and like put them together?
Yeah, like put them together, and then you would have to kind of overlay one more and make them all overlap. It's
So if you fit those all together, you're saying that that's a
cylinder.
that's a
Yeah.
cylinder?
You just have to, the 2 that are going in the same direction, you just have to overlay the bases with one another.
Wow.
I mean, I think. No one ever told me that. I just thought about it.
No, I don't think that that's right.
Why?
There's no way. There's no way.
That's your whole reasoning? It
There's no
says
way.
it in the formula, Graham. It says exactly that in the formula.
That 3 cones become wow. Wow, look at this. Viewer, can you see this? Let me make it a little bit smaller.
Wow. So you believe it when you find it on the internet and not from
Wow.
my beautiful
I see.
explanation.
Wait. Oh, wait. I believe. Oh no. How can it be?
You,
That is incredible.
Graham, think about this on your own time,
Oh
okay?
no, Margaret.
Yo.
See that those green cones? They're half cones.
Yeah, Graham, because it's
They're cut in
awkward.
half.
It's awkward.
I thought you were saying that 3 perfect cylinders, cones would be turned into 1 perfect cylinder.
You have to like squish them around, and it's just like the volume, Graham. You just move the
I
volume
see.
around so
I
it
see.
all fits
All right.
together.
All right. Moving on.
Yeah. Volume of the cylinder, base times height, which is pi r squared times height of the cylinder.
Yep.
So yeah, basically every time in volumes of shapes, the 3D shapes, when you see this capital B, it means you're finding a volume of a specific two-dimensional shape, and you just have to kind of look at the situation and figure out what area of the two-dimensional shape you have to find.
Beautiful.
Okay, surface area of a cylinder is equal to. What do you think, Graham? You had some good ideas for this?
Yeah, so I'm thinking that we're gonna have 2 times the, what is that? Is that called the base?
Yeah.
2 times the base, because those are the 2 circles on either end of the cylinder. And then we got to fill in the dots. I'm gonna sneak a look over to our cheeky cone surface area. A roo doo doo doo
It's
doo. A roo doo 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 doo.
a bit different. Well,
All
actually,
right, help me out. Throw me a bone.
yeah. Add two pi RH. That's what you add. And that's that part.
Pi.
No,
R.
plus, Graham, plus. You have to do a plus. You're adding it together. You take the area of the circle, you add the area of the base circle, and then you add this area.
Plus 2 pi R H.
Yeah. Like that. You could
Now
even
again, I would put in parentheses. I pop parentheses like
where
candy,
even
and
would
it
parentheses
helps.
go? If you still can't remember that multiplication comes before addition at this stage in your life,
Margaret,
I don't know if
it
I
is
can help
how some minds work in powerful ways. I think mine is one of them, and the parentheses helps, focus that raw computational power
I
in a
might
helpful way.
cry myself to sleep tonight.
Okay. All right.
Anyways, another way you could write this formula, if you're just thinking about it and can't remember it, you could just write pi r squared plus pi r squared plus 2 pi RH. There's a lot of different ways you can write all these formulas. There's no real right or wrong answer, unless, of course,
Uh, as somebody who's found the wrong answer for
you do the
many a
wrong
math question,
thing.
Margaret isn't telling the complete story in saying there's no wrong answer.
There are plenty of wrong answers. There are just also multiple right answers. That's maybe a better way of putting it.
That's such a good way of putting it. It's such a better way of saying there are no wrong answers when talking about math.
Yeah, that one.
Math's one of those things. There
That was a
really
little
are wrong answers.
All right, rectangular prism time.
Let's do it.
Do it next to the pyramid, because yeah,
Okay,
because this one kind
that's
of
good.
goes along. Like cylinder and cone go together, pyramid and rectangular prism kind of go together in certain ways. Anyways, volume's the same as volume of a cylinder. Volume equals base times height with the capital B.
Man,
But again,
man.
in this case, the base is a square, whereas with a cylinder, the base was a circle. So the area is not going to be pi r squared. The area is going to be, a length times width, or a base, whatever letters you want to use, x times y.
And I'm not struggling to draw.
No, I think you're doing good. I think it's just off the screen.
For real? You can't see it?
Yes, correct.
Oh, zoom out. Do I need to bring that in? Bring it closer to the pyramid? Zoom in again.
Yeah. No, that's fine. It does look a little bit like a cube, but I guess a cube is a specific type of a rectangular prism, so.
You know what? Here we go. I'm gonna redraw it closer and make it more like a rectangle, because that's what I do. So rectangular prism.
Lovely.
Okay, let's talk volume.
Let's talk
Do you
volume.
think I can? Do you think I can just think this out?
I mean, I have already said it, but yeah, think it out.
Well, when I was in drawing mode. Every good mathematician, their brain is closed while they're drawing. So I'm thinking we've got the area. Thinking. So we've got one, two, three, four. One, two,
There's
four
six.
sides. There's six sides, but four of them are the same,
Yep.
and two of them are the same.
Yeah. I think the direction
So
you're going in now will be more
it's
helpful
surface
for
area.
the surface area.
For surface area.
Yeah.
All right, just throw me a bone. What's the volume?
Base times height.
Sure.
A classic. Capital B though.
I thought we could make up whatever we wanted. Base times height, lowercase h.
Yeah, you can, yeah, that's fine. You can make up whatever you want, except for a lowercase b for these volumes.
Okay. Seems a little silly.
In this case, Graham, the two ends, like there's two sides that are the same, right?
And base times height is this base.
No. The base is the two matching sides, not the four matching sides. So they look like squares
Oh,
in this one, but they could be
beautiful.
a rectangle if you want. The way I did it on my notes was I made each side B1, B sub 1 and B sub 2. So then that way capital B was B sub 1 times B sub 2. Because we already know how to find the area of a two-dimensional rectangle or a two-dimensional square.
Beautiful.
Yeah, and then height is the length from base to base. In this case, if you stand it on an end,
Beautiful.
it's like more traditional height. Anyways, you know how to do it now. Bum, bum, bum. Yeah, and basically remember that three cone into a cylinder thing?
Yeah. Boy, do I remember that.
Do that same thing with a pyramid.
Sure.
Volume is one
Um.
base times height. And
Oh.
square base.
Okay. So then
Same concept.
three of them.
Yeah.
That's very cool. That's
You
very cool,
just,
and I
yeah,
hope
you just have
that
to
our listeners' brain it's clicking a little bit. But
yeah.
hey, listener, who it's not clicking right now. I've been there, and that's okay. And you can still
Everyone
be a
has,
math person.
I have been there. We have all been there.
It's clicking for Graham and Margaret. Oh no, maybe I'm not a math person. Yes, you are.
Oh, you're in 11th grade and oh, it's clicking for Dan and Tommy and all the other kids and not clicking for
And
Margaret.
Anubhav.
Yeah.
By the way, we don't have to unpack that.
We
He's very
eventually
good at
got
math.
there. We eventually
Yeah.
got there.
Yep.
Yeah, I hope the real Dan and Tommy never listen to this podcast.
Oh yeah.
But I didn't say any last names, so we're good to go. Those are very common American names. I think I'm okay.
All right. Surface area here is
Just find the area of each side, add them all together. Don't even bother
just
memorizing a formula for this. It's just
I'm just gonna say
just-
friggin' add them up.
they're all rectangles. Find the area of the two matching rectangles, multiply that times 2. Find the area of the 4 matching rectangles, multiply that by 4, add it together.
Yep.
You're all,
Yep.
just don't even bother
Beautiful.
wasting your brain space with memorizing a formula for that. Just understand the concept and move on with your life.
Huh. That is an interesting thing to say. Understanding math from a holistic perspective, hold for applause, versus just memorizing formulas. This is not a memorized formula podcast, even though we are going over a lot of formulas.
Is not. And it's because I have forgotten most of the formulas by now. And I am still able to do the math eventually. normally after I Google the formulas. But sorry. Cool. Let's do
Are we getting
triangular
money
prism.
from Google, by the way?
Let's do a triangular prism, Graham. It's really the same. So just do it really fast because I'm getting bored of this whole subject. And probably our listener is too. It's like how much volume?
No, listener is captivated. Listener has been listening for what, 45 to 50 minutes
No, okay,
now, and is
faster. Speed it up. Triangular prism. Same as the rectangular prism, only instead of a rectangle at the bottom, it's a triangle.
oh, I see. I messed that up.
Volume is base times height. Only here, the area of the base is an area of a triangle, 1/2 base times height, lowercase. And then surface area, same thing, add them all up. Really could not
Oh,
get
so
it.
that's like a tenth.
I mean, if
Volume
you
is one
saw it
half.
that way, yeah. And for all you wilderness experts out there, which I'm sure is most of you, because
Could be.
I would identify myself as a wilderness
You
expert.
run in those crowds.
If you for some reason are using a tent like from the 1970s, this formula will help you find how much space is in your tent.
All right, surface area.
Add it all up. Add it all up.
Add
Add up the area of all the sides.
up. Beautiful.
Yeah. Like someone came up with a formula on the internet. Of course, I think that it makes it harder. Like I'm not gonna memorize that formula. I'm
I
just
agree.
gonna do it this way.
Honestly, I think this whiteboard is really nice. We could maybe make merch one day.
True. I mean, I love a good sphere on a t-shirt. Maybe even a cone.
Perhaps polyoid or whatever that thing we went over. Ilioid,
An
the circle
ellipsoid?
thing. Ellipsoid, that's it.
In the merch, we'll label the shapes, so then you
Yeah.
have to memorize.
Yep.
Cool. Graham. Oh, this is just for fun. I wrote at the bottom of my notes. You figure it out. I didn't write the answers. For a hemisphere.
Okay. So what we're doing there is we've got our sphere, something like this.
Yeah. So volume, real easy. Just half the volume of a sphere, right? So volume equals
Right.
2 pi r cubed.
Equals what?
Volume equals 2/3 pi r cubed. Right? Because that's half. And now let's see if I can pull off
What was
it.
the volume of a sphere? What was the volume of a sphere?
Graham, it's written on the whiteboard.
No, I don't see it. Oh, sphere. Yeah. 4/3.
Yeah.
Oh, yeah. Divide by 2.
Yeah.
Beautiful.
Cool. Then surface area of a hemisphere, a little more complicated. First, let the
No.
surface area of the sphere in half. So
Oh, I guess it is more complicated.
yeah,
You're
surface area
right.
equals 2 pi r squared plus the area of the circle, which is the base, which is pi
Right.
r squared.
I'll just say A. Oh, what? Would you rather me say B?
No, I don't care. Just label A or color it in or something. Yeah.
There we go.
And that's gonna be pi r squared. So there you have it. And then, we could take things a few steps further. Let's say you're, instead of a rectangular prism or a triangular prism, say you're making a prism where the base is a pentagon,
Oh,
you know?
goddamn.
So this is an example
All right.
where
Pentagon.
you're gonna have to sit and think about it and figure it out. I forget the area of a pentagon off the top of my head.
Man.
There definitely is a formula for it. This would be a classic Google situation. Yeah.
Wow, that's a spicy thing
Oh, you
to
made
try to solve.
a pyramid with a base of yeah. So you
Of
do,
a pentagon.
yeah. So you'd find the area of a pentagon, you'd look that up, you'd calculate
Yep.
it. So that would
Uh-huh.
be your B for capital B.
Yeah. The
Height is the
base.
same,
Uh-huh.
the
Uh-huh.
height of the
Yeah,
pyramid.
yeah.
And you do
Hmm.
1/3 base times height. Same.
Really?
I think. I mean, I don't know for sure, but I
Pyramid.
assume
Because
so.
it's a pyramid.
Yeah, that is my best guess. And if I'm wrong, I'm sure the internet will let me know.
So listener, if you ever want to be like in real estate, somebody's like, "Oh, what's the square footage?" Hey, that's math. That is math. You take some dimensions. You you're like, "Okay, well, am I looking at a sphere? Is this house a sphere? Yes, no. Is this house a cone? Yes, no."
Yes. Also, with square footage, you're really not going to be calculating volume or surface area at all because you'd just be calculating the area of the floors of the house.
When I'm looking at houses, I always ask about surface area because I want to know the walls and stuff.
I like volume because
Huh.
then it has ceiling height involved as
Uh-huh.
well. And that could
Uh-huh.
be fun.
Oh, the life of being a math person trying to buy a house.
Yeah, so basically you can now find the volume or surface area of any shape you want, any shape in the world, because we've shown you a lot of shapes here. But then there's a lot of different shapes out there in the real world, and you can just cut those different shapes up until they match these shapes that we've shown you. And then you find the volume and surface area of the shapes that match the ones we've shown you, and then you add them back up, and then you have your little volume of your weirdo shape.
And what we're going to do is we're going to challenge the listener to come up with a shape that cannot be reconstructed using these shapes that we have gone over today. It's impossible, but I want you to try anyways. You can put your suggestions in the comments because this is only going to be on YouTube for now. We're
And
working on a website.
it must be a hand drawing.
Yeah, and we
Mainly because I
guarantee
think it will be funny because it's really hard to draw a good 3D drawing of a shape.
we will do the math. We will give you the surface area and volume of any shape using just these shapes.
And we're excited. All right, Graham, I think we can kind of do a little here and let's
Cut
switch over to related rates, but I think that would be best as a whole new episode.
as a new episode.
Yeah, but I'd like to keep recording. I think we can talk about related rates.
You want to bang out another episode right now?
Yeah. Although,
Add a page.
I don't know, do you think that episode was even any good?
I think it got better when we weren't doing the ellipsoid.
Now there's a quote for the ages.